Welcome to this video lecture on the subject Optical and Microwave Engineering. In this lecture, we are going to discuss about circulator and isolators. So microwave circulators is 3-port non-reciprocal passive device. So this circulator is used to direct a microwave signal from one port to the next immediate port in this, so acting as a unidirectional energy flow path. So the characteristics of circulators are, so first one is non-reciprocal. Here it means the transmission characteristics are not same in both the directions. So the behavior of the circulator differs significantly depending on the direction of signal flow. So on 3 or 4 ports, so it consists of 3 or 4 ports where the signals can enter and exit, and also unidirectional flow. And working principle of circulators. So first one, magnetic field. The ferrite magnetic material is magnetized, and the interaction between the microwave signal and the magnetic field creates the non-reciprocal behavior. And wave propagation. The microwave signal entering one port is coupled into the ferrite material while it propagates along a specific path determined by the magnetic field, and the signal is then transmitted to the next port in clockwise direction with minimal loss in the forward direction. And also it provides a high isolation in the reverse direction so that only unidirectional flow is achieved. And applications of circulators include duplexer circuit, isolators, and reflection amplifier and radar systems, amplifier systems, and antenna transmitting or receiving. And this is the example of microwave circulator schematic. So here consists of 4 ports in which the power flows from port 1 to port 2 and port 2 to port 3 like this in unidirectional way. So 4-port microwave circulator constructed using the directional couplers. Here 2 3 dB couplers are used and 2 phase shifters are used. So this can be used as the 4-port microwave circulator where the input wave arriving from port 1, it is phase shifted by the phase shifter by 180 degree and it arrives at port 2. Similarly, the wave is going to couplers get 90 degree phase shift and coupler 2 also 90 degree phase shift. So it arrives with 180 degree phase shift at port 2. So these two waves are added at the port 2. So we get the unidirectional flow from port 1 to port 2. So remaining port, the wave is cancelled. So it is isolated port. And we get S matrix of circulator like this. For a perfectly matched lossless circulator, we get S matrix as from S11 to S44. We get values for 0, 0, 0, 1. In this first row, value of S14 becomes 1 because from the wave travels from port 4 to port 1. Like this, for the remaining rows, we get S21 value as 1 and S32 is 1 and S43 is 1. So this is the S matrix of circulator. So next we are going to discuss about the microwave isolators. An isolator is a non-reciprocal transmission device. So it is also used to isolate one component from reflections from other components of the transmission line. For example, if we have a source and like klystron, so we need to isolate the component from the load reflections. So an ideal isolator completely absorbs the power from the propagation in one direction and provides lossless transmission in the opposite direction. So this isolator is called as a uniline. And isolators are generally used to improve the frequency stability of microwave generators such as klystrons and magnetrons, in which reflection from the load affects the generating frequency. And the S matrix of isolator is written using 2 cross 2 matrix. So here 0, 0, 1, 0. So S21 value we get as 1. And working of isolator. To achieve the non-reciprocity, an isolator must necessarily incorporate a non-reciprocal material. So this material is usually a ferrite which is biased by the static magnetic field, and ferrite is positioned within the isolator such that microwave signal presents it with rotating magnetic field, with rotation axis aligned with the direction of the static bias field. So the behavior of the ferrite depends on the sense of rotation with respect to the bias field. So here we can see the diagram for Faraday rotation isolator. Here the input resistive card is in YZ plane and output resistive card is displaced 45 degree with respect to the input card. So DC magnetic field which is applied longitudinally to the ferrite rod, which rotates the wave plane polarization by 45 degree. And applications of isolators. So here we can use it for us for klystron frequency stability and also radar applications. Let's take the assessment. Example of non-reciprocal device. So the answer is circulator, and attenuation of dash is very large near to the gyromagnetic resonance of the ferrite. So the answer is option B, it is circularly polarized wave. Thank you for listening this lecture.